Welcome to another Back of the Net recording. I'm trying out something new on the iPad here. Hopefully it'll work. It's not really so much of a very clear, explicit how to do something. It's just me looking a little bit at some circle theorems and showing you how I might solve them and how you might go about solving them in an exam. Right, so first of all, I've just got circle theorems here. And I just realised I've got a little pointer thing I can point with, so it says circle theorems. Okay. I've tried to come up with a way of helping remember some of those circle theorems, and I thought if we could try and remember the acronym quadrilateral. So you've got QUEST there, Q-U-E-S-T, QUEST, and that stands for quadrilateral. Ice cream, equal angles, semicircle, and tangent. What I'm going to do now is have a little look around and see if we can get some of those things. So let's remember QUEST, quadrilateral, ice cream, equal angles, semicircle, and tangent. And hopefully when you come to tackle a question, you better apply the QUEST idea to it and see if that will help you solve any of your problems. First of all, let's just have a little look around, and I've photographed some other bits and bobs that may help. So this is an example of a circle theorem here, and it says angles subtended by an arc. Let me get my pointer finger back there. Angles subtended by an arc in the same segment of a circle are equal. So this is what I call the equal angles from the same arc. They're basically saying if you have a line here, any angle you draw from that line will be the same at the circumference. So angle X, Y, and Z will all be the same because they're all growing from that point there. Now I know some of you in the past I've spoken to about like having some trousers on there. So if you were to draw from that angle there, let me just get my pen a little bit thicker a sec. Still not quite used to it. Okay, so we've got angle X there and it goes back to there. I sometimes say, well, let's imagine that we've just got a little bit of a shoe on there, or a boot on there if you like. So draw some shoes on there, not sort of shoe it is. And on the bottom here we've got another similar type of shoe. Is there another pair of trousers that could fit onto that shoe? Well, clearly there is, because I could just as easily have a pair of trousers that would fit onto that one there, or that one there. And we see the angle at the top of all of those. So this angle, and this angle will always be equal. That's the equal angle one. And going back to our quest, that there was the one that we called equal angles. Let's go and see, there's another one here we can look at. Let's look at this one here. Okay, let me just get that one up to the front. Sorry, wrong thing there. Get this one up to the front. There we go. Okay, so looking at this one, we've still got that type of idea there from the same arc. We've got an arc here between 2 points, A and B, between A and B. And we've drawn up to the circumference and down again. But in this case, there's not another one over here or one over here. This time, it's gone up to the centre and then down again. So this is the one where the angle at the centre is twice that at the circumference. So if that was X, this one here is 2X. Now I'm not sure I actually had anything to help you remember that one. Let's go back and have another look. Let me just get used to using this. Click on that one there, and let's just move that out of the way and go back down to our quest. Quadrilateral, equal angles, we haven't got twice. I'd be quite tempted now then to change that one that says tangent, and I'm going to call that twice instead. So we'll learn as we go here. Happy with that. Okay, so that's going to be my twice one. Okay, there we go. What's this one here? Looking at this one here, well, although I can't see a semicircle, I actually know that this line across here is a diameter, and it must be the diameter because it's going from point B, which is on the circumference, across to point A, and then this bit will be going round. And because it's gone through the centre, that must, of course, be a semicircle. So all around there is a semicircle. I'm just going to undo that and try and get a bit nearer the line if I can. Doesn't seem to want to let me. But that will tell me then that this angle in here, up to the semicircle and back again, is a right angle. That's really important. Very rarely do you see it drawn in a semicircle. Much more often it's part of a circle where the circle has been cut in half to make a semicircle by a diameter. Okay, let's just close that one down a little bit and go back down and see if we've got any more here under circle theorems. So we've done semicircle, we've done equal angles. Have we done twice? Yes, we did do twice, so the angle at the centre is twice that of the circumference. So we're looking for ice cream. Okay, looking at this one here. Let's just enlarge that, and I'll click on it now just to... Sorry, that's wrong. Click on that one there, just to bring it... I've done it wrong again. Which is the button I need for that? I think it is. Okay, I'm trying to find this piece here. Sorry about that complete mistake. So this one here, I want to try and select that and bring it to the front, but I can't remember which bar. It's that one now, I've got it now. It's this one here I need. Bring it to the front. Okay, here we go. Sorry about that taking so long, that was terrible. Right, okay. Now this one here is what I call the ice cream one. If you look at the circle here, that's like ice cream ball that's just put into a cone. There we go. Now first of all, it will always be at right angles. The diameter there, sorry, the circumference there. So again, the radius there will be at right angles to the other bit. Okay. And also it will always fill exactly into the ice cream cone. The blue bit is the ice cream cone, and that is above ice cream. So the distance, I'm just going to have to try and get my pen a little bit smaller. The distance from there to there, from the point there to there, will be the same as the distance there to there. So those two distances will be the same. And that's why I call it the ice cream cone, because that ice cream ball, if I now attempt to pick this up and twist it around, as that ice cream falls down, as your ice cream falls down into the ice cream cone, down into here, it's going to sit exactly in the middle. So this distance here will be exactly the same as this distance here. The other one that comes with that ice cream idea is something called the alternate angle one. Here it is, the alternate segment theorem. And it's basically saying that this angle here, when you have a tangent, this angle will be the same as that angle in the triangle drawn in there. And similarly, that this angle here will be the same as that one there. I think that's one of the hardest ones to get a grasp of. Okay, let's just minimize that a little bit. And finally, we've got this one here. Now this is a quadrilateral, it's got a four-sided shape. It's called a cyclic quadrilateral because it fits exactly in a circle. And the rule for that is that the opposite angles are equal. Sorry, that's not true. The opposite angles sum up to 180. So this angle here and this angle here will add to 180 degrees. Angle A plus angle C is 180 degrees. And similarly, angle B plus angle D will also come to 180 degrees. There's a proof of that, but I'm not going to show you that now. I'm not going to do any proofs here, I'm just letting you see what they are. So there we've got this one here, quadrilateral. This one here, ice cream, that's about tangents of 90 degrees, and also that the distance is, lost it, here, will be the same as the distance there. This one down here, this one is the idea that it's a right angle in a semicircle. And if I go looking over here somewhere, this one here, the idea that the angle at the centre is twice that of the circumference. And finally, we have one down here, which is that all the angles have tended from the same arc, like the trouser ones. They're going to all be equal as well. Okay, right. The other thing I've done now is put a few questions in it for us to have a look at. And in each of these questions, we're trying to find what the letter is. So looking at this question here, I can apply my quest things, and quite quickly, straight away, I can see what have I got here. Quite clearly, what I've got here along there, down there, across there is a quadrilateral. So this is my cyclic quadrilateral one. And we remember from that one that what that said was that the opposite angles add up to 180 degrees. So straight away from there, I can say that 86 plus angle A has got to be equal to 180 degrees. Therefore, angle A is going to be 180 degrees. Subtract 86, which will of course give you 94. So A equals 94. And you can write cyclic quad, comma, opposite angles, sum to 180 degrees. And similarly, if we look at angle B here, this angle B here, we know that that plus 105 plus angle B has got to be equal to 180 degrees also. So 180 minus 105 is going to be equal to B. So B must be 75. And again, the reason for that is, I could write a different way, opposite angles in cyclic quad, sum to 180 degrees. Okay, let's go looking for another question. Have we got anything? Oh, there's one over here. Right, this one looks a bit more challenging to me. Let's have a close look at that. Let's move it up there. Okay, what do I know? Looking at this question first of all, I'm just going to see if there's any things in there I already know. Now, one thing I've not spoken about so far is how important it can be to label the radiuses. And when I say label, I will use a highlighter and colour them in so that you know. Just going to change the colour of my pen there if I can in a minute. So that you know that they are the same. So I can see straight away that that's a radius, that's a radius, and that's a radius. So already I know that this side here, just about to highlight, sorry, this one and this one will be equal. It's a nice sausage triangle. And this one will be equal. So straight away, I've already worked out just by doing that the angle in here is indeed 58 degrees. I want to make that look more like an 8. I'm struggling with a pen here. Okay, I'm just going to write over here to remember that. B equals 58 degrees. Okay. The other thing I've got here, I've noticed, it's gone through the centre. This line here has gone through the centre, so it's a diameter. This here is a diameter. So this must be a semicircle. So I now know that this here is a right angle. So A is equal to 90 degrees. I'm actually trying to find angle Y. So far, I haven't found it. So that's not too great, is it? Let's have another look at this question. I'm exactly like you when I'm trying to do an exam, trying to work out what on earth everything can be, and I've just realised what it is. If this here, let me get my pointer, this here was a semicircle, then that there too must be a semicircle. So I'm going to now write in the angle there, A, little a, actually let's call it alpha instead. So alpha has got to be, plus 58 has got to be equal to 90 degrees. And that reason for that is that angles in semicircle are 90 degrees. Okay, so alpha therefore has got to be 90, minus 58, which of course gives us 32. Now, because this triangle here is an equilateral, an isosceles triangle, and we did that at the start by marking those in, that's an isosceles triangle, y must also therefore be, y equals 32 degrees, isosceles triangle. Okay. Well, I found y. That's the only one I wanted. That was lucky. So, as you can see there are a few things I did. First of all, I was very careful to mark on all the radii I had, so that I was able to identify any equilateral triangles, like that one, and then I was able to spot that one. I was a bit slow in noticing that this was diameter, but as soon as I did, I got that one there. I didn't actually ever need that one there, but that made me realise suddenly that there was also a semicircle and helped me solve the problem in the end. There's no quick way, just got to keep looking, see what we can do. Alright, okay, let's have a little look. What have we got? We've got one there to do. Let's have a look at this one here. I've got no particular reason or order I'm doing these in. Here we go. There's a lot going on in this one. Notice this time now that we don't actually have that point there being at the centre. So I don't know that these sides here are all equal. One thing I've just realised, I'm going to try and make it a little bit bigger if I can, a second, just bear with me. So I can actually find it a little bit easier to write stuff in than I did last time. Right, what I've got here is what we used to call an X angle. This here is an X angle, so straight away I know that this angle here is 96 degrees. Was there any point in that? Yes, there was, because now I've got another triangle. Let's just highlight that triangle. I want to go for it in pink. Take that down a bit. Okay, this triangle here is, of course, a triangle in its own right. So those have got to sum up to 180 degrees. So y plus 96 plus 50 has got to equal 180. The reason for that is opposite angles, and then angles in triangle sum to 180 degrees. Therefore, y equals, let me just work that out. So I have to do 180, subtract the 96, subtract the 50, equals 34. 34 degrees. Okay, I'm not there yet. I've now got to find out what angle x is. Let's have a think about that. Well, it's quite a tricky one, this one. I'm just going to change my colour pen there to a different colour so we can do a bit more annotation without it being too tricky for you. What I've got here is a cyclic quadrilateral, because that quadrilateral is drawn in a circle. Okay, and I know from one of my rules, my quadrilateral rule in Quest, that the opposite angles are equal. So I know that all of this angle here, so I was wrong what I said, they're not equal, they add to 180 degrees. Sum to 180. So 40 and y I've just worked out was 34. So 34 plus my 40 will give me 74. So that angle in there is 74 degrees. So all of this angle here has got to add up to, with this one, the 74, 180. So therefore, this must be 106 degrees. Okay, I'm getting a little bit better, but I'm still not there. Right. Okay. I know all of that's 106 degrees. I've now got to try, I need to try and split this angle here up somehow and find what this one here is going to be. I'll tell you what I'm going to go for there. I think I've got this. I know that's 96. These here is on a straight line. This angle here is a straight line. So that's 96. So 180 minus the 96 gives me 84. So this angle, this angle in here is 84 degrees. 84 degrees and the 40 at that angle there have got to equal 180. So 84 plus my 40 is 124. 180 subtract the 124 leaves me 56. So that angle in there is 56 degrees. Right, how has that helped me? Probably not a lot. I'm struggling with this one at the moment. Just keep working around till I get more and more of them done. I also know that that there is 84 by opposite angles. Oh, and that's not going to help, is it? 84, 150. I know what that one there is. I could do with knowing what this one here is. I expect some of you are seeing this and it's staring me right in the face. But I can't do it at the minute. That's angle X. That should have been, because it's X, it should be in the first one I was able to find, so why couldn't I do it? 96. It's not necessarily an isosceles triangle, though it looks like one. Sorry, this is really going to bore you, isn't it? All of that is 106, I know that. That's 96. I'm just thinking, can I use all of that? And I can't. I don't know what that missing bit there is. Is there a way of working that missing bit out? No. Do you know what? When I come back to that in a minute, I'll do another question whilst I try and solve how to do that one there. Okay, let's look at this question here. Number 13. Hopefully this is more lucky than the last one. Okay, right, straight away when I look at this one, I'm feeling a bit more confident because straight away I've spotted that this here, or either here, is a semicircle. So I know that angle B must be, all of that is 90 degrees. There we go. I also know that those sides are equal, so this bit in here must be 42 degrees. That's 42 degrees because it's an isosceles. Let's just call that, I don't know, again, I'll go for angle alpha. I can write alpha equals 42 degrees because it's an isosceles triangle. Okay, that's 42 degrees. I know all that's 90, so I can therefore work out that this must be 40. So 90 subtract the 42 is 48. So I know that this angle here is 48 degrees. So angle beta equals 48 degrees. And that is because angles in semicircle sum to 90 degrees. That's not right, it's not sum to 90 degrees at all. Angles in semicircle are 90 degrees. It's not the true definition. So we know that that is 48 degrees. And then because of isosceles, x also 48 degrees. The reason for that is it's an isosceles triangle. Okay, bit better with that one than the last one, wasn't I? Right, let's go looking for another one. Anything else out there? Oh, we've still got a few to do, haven't we? Let's go for this one here. This is looking very complicated. As you can see, there is no quick way of doing it. Just got to work through them and try and get there. Still disappointed I couldn't do the other one. This one's quite nice. Looking at it, let's have a little think what I can see. Okay, let's try again. Here we go in. So I don't know what happened there. Looking at this one here. Okay, I'm seeing straight away, straight line down there. That tells me that this little angle in here is going to be 40 degrees. Okay, I'm now also spotting straight away a isosceles triangle. So marked on by those 2 points. So that's 40. That leaves me with 140 to share between these two. So those two there are going to have to be 70 each. And that one there's also going to be 70 degrees. Okay, how does that help me anymore? Right, okay, as well as all that, we've now also got a cyclic quadrilateral. Boom, 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 boom. That tells me that this angle and this one must add up to 180 degrees. Therefore, in here, that's got to be 110 degrees. Okay, if that's 110 degrees, I've also got a triangle here. Let me point my pointer. I've got an isosceles triangle there. That's 110. That leaves me with 70 to share between this angle and this angle. Therefore, they must equally be 30 degrees. And that one there will be 30 degrees. So y equals 30 degrees. Y equals 30 degrees. I'm not going to go through and explain all that. You could have written your own explanation all the way down there to explain how you got there. I know it's a bit lazy, but I am aware that this is getting to be quite a long video, much longer than I intended. Okay. Have we got any other questions to answer? We got this one here I still can't do. See what, I might leave that and let you tell me how to do it. I'll have a look at it and maybe come back and add to it later on. Finally, let's have a little go at this one here. This is looking really complicated. Looking at it, the first thing I notice, I've got, a diameter there. So that there must be 90 and that there must be 90. So let's try and write those in. But before I do that, I'm going to make it a little bit bigger. Here we go, right. So that and there is 90 degrees. This one here is 90 degrees. Okay. Well, in there, that must be 50 degrees. And I know that's 50 degrees because it's opposite angles. So 90 and 50 makes 140. And of course, what we have here is another triangle. And we've got 140, so B must also be 40. That's that one works out. We've done B. I haven't even looked at angle A yet, but I can see that. I'm getting there quite quick now with angle A. Straight line across here. That angle there's 50, so the bit in there must be 130 to add up on the straight line. If that's 130, that's 130, that's 18, that makes 148, which leaves me with 32 to make up to the triangle. So A equals 32. Okay, I've only got to do C now. That's not so hard either, because straight away I've just noticed I've got a triangle there. I knew that was 90, I knew that was 18, so far I'm on, I think, 108, 18, 108, 108, that leaves me at a 72 required. So A plus C has got to equal 72 to make up my triangle. I already know that A is 32, therefore C must equal 40. Okay, that needs quite a lot of explanation to explain how you got there. But like I said, this wasn't particularly about formally doing an exam question. This was much more about how you would go about solving some of these circle theorem problems, just a way of doing them. And as you can see, it's not always easy, because I've just gone back to this one. I am still really struggling with this. Let me just have a little think a sec. Okay, I'm still looking, still can't find it. I've had a quick look at the answer book and they've told me that it's 34, which would mean they're saying that this angle here is a right angle. They'll be telling me that this angle here is a right angle, and I cannot find out any reason why that would be a right angle at the minute. I'm going to have to admit defeat on this one for the moment. Any of you in my current 11 BG group, if you can come up with a reason why that angle X there is 34, I think there's probably a fiver in it for you. Okay, so I'm being defeated. If you do know, email me, let me know. Okay, I'm hoping though, apart from not being able to do that one question there, this whole thing here on circle theorems has been helpful to you and will allow you to realise that they are quite tough questions. Just got to keep working at it, see what you can get. Best thing to remember though is use that quest. It will really help you look at the things you're doing. I suppose, to be honest with you, I should have been doing that a little bit more when I was looking at the question here I couldn't do. This one here, I should have been thinking quest. I've looked at the quadrilateral, I've done that. Equal angles, or could it be that? Do you know what it is? There you go. That's why you should have used quest. I can't believe I've done it. Look, how silly was I? I'll go for the blue. In fact, let's not go for the blue, let's go for a completely different colour. Let's go for green and show you, look. I know that angle there is 56. Sorry, make that a little bit thicker. Gosh, some of you will be thinking you're so thick, not going to do that. Look, there we go. That line up to there and down to there. I know that angle in the top here is 56. I'll draw my little shoe boot idea on there and a little boot on there, a bit thick. Up there, that is the same angle. It's from the same pair of trousers, if you like. So Z equals 56. So I now know that Z equals 56. So Z equals 56 degrees, and that is equal angle from same arc. How annoying is that, not seeing that? That's maybe quite cross. Let's see if we've got any more. Let's do it again. Let's use the same technique I just did there. Let's go for a bit of yellow pen. Let's not go for yellow, let's go for red. So you can see what I'm doing. The angle I want here, so I want to be a bit thicker as well. The angle I want there, I've got angle X, so let's trace that back. Angle X goes back to there and back to there from those 2 points. Is there another one? Yes, there is, from those same 2 trousers, there and there. And it's angle Y. So that's why it is 34. I should have spotted that when I saw that 34 there. That has made me quite cross. Never mind. It's shown you that we are all infallible, and you haven't got a chance of a fiver. So Y is equal to X, and that is equal angles from same arc. Therefore, X also equals 34. Oh, annoying, annoying, annoying. Anyway, there you go. I got there in the end. Bit of perseverance. And actually, what was the thing that did it for me? I can't believe this. I gave it this whole quest thing to make it easy for you, and lo and behold, it helped me. Never realised how powerful that could be. Right, you've got to learn quest from now on. Okay, hope that's useful to you. Do tune in for another recording. Thank you very much. Let's see if we can go back. Nope, it's not that one.